Find the element that appears once in a sorted array. So the problem statement is given a sorted array consisting of only integers where every element appears twice except for one element which appear once. Find this single element that appears only once. So if you see this example, this is the sorted array where every element appears twice except one, which is 2. So the output is 2. And similarly, if you see this second example where every element appears twice except 10, so the 10 is the output. So we have to find the single element which appears only once. So in this tutorial I am going to discuss two approaches to solve this problem. The first approach is to traverse an array and create and find the count of each number. Once we know the count of each number, then the number which has count of 1 is the output which we required. So we can create a number and its count using map. So let's see how we can do it. And so this is the code where I'm creating a map, and after that I am traversing a map and checking if the count is equal to 1, then return this integer. So let's see how this code is working. So let's create a map. So map is nothing but a key value pair. Map is just a key value pair. So here key is my number and value is its count. So I have declared a map of integer and integer type. So key is my integer and value, the count of that number is also an integer. Now I am traversing an array, and so if you see the first element of an array is 1, which is not present in a map. So initially I put its value 1. Now next time the next element of an array is 1, so it is already present in a map, so I increment its count, it's 2. Similarly for 2, the count I keep in a map is 2. For 3 it's 2. Now the 4 occurs only once. Now 5 is also present twice in an array, and 6 is also present twice. So now I have created a map of number and its count. So this is what this line does. So it put the value in a map. So this is my number, and this what this line does is it checks whether the value is present in a map. If it present, so it just get the value and add 1 to it, otherwise it set the value 1. And once I created a map, now I'm traversing a map and checking is any value equal to 1. So now we found that this value is equal to 1. So I have declared one variable which has initial value of 0. Then I assign a key in this variable. So key is my number, so I have assigned a number. So I found the number which uh, occurs only once in an array. Then I break the loop and return the result. So the time complexity of this approach is O(n), but you see we are using map, so the space is not a constant, so it's also O of n. So the space complexity is also O of n. So this is the one way to solve this problem. Now let's move to another approach, and in this approach we are using XOR. So we are using the property of XOR, that XOR of a number with itself is 0, and XOR of a number with 0 is number itself. So if you see, if we do the XOR of two similar numbers, then the result is 0. So the idea here is, so every element, so except one, all other elements of an array appears twice, so it will cancel out, and the number which appears once, we get the result. So if you see the truth table of Xor, then 0 Xor 0 is 0, and Xor of 0 and 1 is 1 itself. Xor of 1 and 0 is 1, and Xor of 1 with 1 is 0. So if we represent all this number in bitwise, so let represent all this number in bit representation. So in case of 1, let's represent it 0 0 0 1. Similarly, the second number is 1, so it's 0 0 0 1. For 2, it is 0 0 1 0. Similarly, the next element is 2, so it is 0 0 1 0. Now for 3, it is 0 0 0 and 1 1. The next element is 3, so its bit representation is 0 0 1 1. And for 4, it is 0 1 0 0. And for 5, it is 0 1 0 1. And the last element is also 5, it is 0 1 0 1. And now if you see, 1 1 is already get 0. If you see the truth table, then the next 1 1 is also 0, then this is 0, so the resultant output is 0. And if you see this 1 2 3 4, so it is cancel out, and it's also is become 0. Now 1 1 is 0, and 0 1 is 1, and here all our zeros are present, so it's 0. So if you see, we get this binary representation. If you convert into decimal, then it is 4. So using the Xor property, we can solve this problem. And in Java, we already have this operator which do the Xor. And if you see, I have just traversed an array and do the Xor, and after that I return the result. And this is my main method where I have uh, declared an array. And let's run this code. And if you see, the first, I'm testing uh, with a map method. So let's see the output. So see, the output we get is 4. Now comment this line and uncomment this line. Now let's test this with Xor, and if you see, the output is 4. So these are the two approaches which I have discussed in this tutorial, and in next tutorial I can also discuss how we can solve this problem in O log n time complexity using binary search. And that's it for this video tutorial. For more such programming videos, you can subscribe our YouTube channel. You can visit our website, which is https://webrewrite.com. Thanks for watching this video.